Hello everyone, this is Bahula.
This is Shravya, and this is how our circuit works.
Let's start with the heart of the circuit, which is an LDR. This is how the LDR works. When it's exposed to light, the resistance of the LDR is low, and when it's dark, the resistance is high. One leg of the LDR is connected to the 5 volt and the other to the 10 kilo ohm. The middle part is connected to A0 pin, which is analog 0 pin. We use analog pins because they are used to read the voltages. A0 pin reads the voltage over here. This is the code. Int LDR value is equal to analog read A0, which reads the voltage value and stores it in LDR value. And this is the syntax of map, where the first one is value, and then from low to high, and then from low to high. So int brightness is equal to map of LDR value 0, 1, 2, 0, 1023, 255, and then 0. This is the voltage at A0, which is equal to V in into R bottom by R top plus R bottom, where R bottom is 10 kilo ohm, R top is the resistance of LDR. When it's bright, the resistance is low, which means the numerator is high since it is 10 kilo ohm. The voltage at A0 is high, then it reads 0, which means low DC cycle, which results in no light. And exactly opposite when it's dark. So when it's dark, the light turns on, and when it's bright, the light turns off. And then the code sends a signal to PWM signal to pin D9. And we use and you can have this doubt, why D9 and PWM. It's because PWM allows us to control the brightness along with on and off of the bulb. We use analog 9 comma brightness in our code to send variable voltage to alter the brightness. You can see our circuit over here, and my partner will continue the rest.
Now let us learn about the Bluetooth module. Bluetooth module is used to establish wireless communication between Arduino and your mobile app. The module's TX and RX pins are crucial for sending and receiving data between two devices. Here's what each pin does. TX pin. This is the transmit pin of the Bluetooth module. It sends the data from the Bluetooth module to the Arduino. It connects to the Arduino RX, meaning the data sent by the Bluetooth module will be received by the Arduino pin 2. RX pin. This is the receive pin of the Bluetooth module. It receives the data from the Arduino to the Bluetooth module. It is connected to the Arduino TX, meaning the data from the Arduino will be sent to the Bluetooth module through pin 3. In our project, our study lamp has two modes. One is automatic and other is manual mode. Automatic mode. In automatic mode, the LDR will control the brightness of the LED based on the light levels. The Arduino continuously reads the LDR value and adjusts the brightness of the LED without user intervention. The Bluetooth module doesn't play any direct role in the automatic mode unless you want to use it for the status updates or enable or disable the mode remotely. The second is manual mode. In manual mode, the mobile app sends the commands via Bluetooth to the Arduino, allowing the user to control the brightness of the LED through the app. The app can send specific commands, example, change brightness or turn the LED on or off. The Bluetooth module receives the data and passes it to the Arduino, which then adjusts the light accordingly.
Like my partner said, a study lamp can work in two modes. In auto mode, the brightness of the lamp automatically gets adjusted as per the surrounding brightness, as you can see in this video.
Here you can see the brightness decrease clearly. When you switch on the torch, the LED brightness is 30 to 35. And when it is turned off, the brightness is 250. The other mode is manual mode. We use serial Bluetooth terminal app and connected it to our HC05 Bluetooth module via Bluetooth. Now we can give command from 0 to 255 to alter the brightness of the bulb.
In the app, we have auto mode by default. By pressing M, it changes to manual mode. And then you can give numbers to alter the brightness. 0 for no brightness, 255 for max brightness, 120 to 128 for medium brightness. Let's watch this video.
Challenges faced. We have faced a lot of challenges in both circuit and code. Once our code made our LDR work in reverse. When it's dark, the LED went off, and when it's bright, the LED turned on. Then we figured out that by exchanging two numbers in the code, we can fix this solution.
We also faced problems in the circuit. While uploading the code into the Arduino, we didn't unplug the TX and RX pins, which made the commands turn in loop between the Arduino and Bluetooth, causing no response in the bulb brightness when we give a certain command via Bluetooth app.
To conclude, our study lamp is student friendly.
It changes the brightness on its own depending on the surrounding light, causing no strain to the eyes of the students. At the same time, if the students study for a lot of time, then the students can manually change the brightness as per their convenience using the app via Bluetooth.
Thank you.